Now, generative AI has been around since the 1960s in the forms of chatbot primarily. But it was the introduction of generative adversarial networks, or GANS, in 2014 that has made it possible for generative AI to create convincingly authentic images, videos, and audio. Now, fast forward to 2024, and attention is now focused on foundation models and the role these play as organizations race to have in place successful AI strategies. Joining us on VODCHATS for FutureCIO is Mr. Luv Aggarwal, Worldwide Sales Leader for IBM watsonx.ai, to help us understand how enterprises can leverage the foundation models that underpin enterprises' AI strategies moving forward. Luv, thank you for joining us on VODCHATS for FutureCIO.
It's an absolute pleasure to be here. Thank you for having me.
Recap for us, what is the relationship between artificial intelligence or generative AI, for example, and these foundation models? How are the two connected?
Yes, absolutely. So generative AI is a much broader term, right? Being a subset of AI. And when we talk about foundation models, these are models that have been trained on very, very vast sets of training data that incorporate knowledge from the internet or other repositories of data. And what you get at the end is something that's very generally adoptable to different types of use cases, right? So think of it as I've taken a bunch of data, from the internet, from various different sources, filtered it down into a model that is able to understand general language, as one example with large language models that are a type of foundation model.
So how have organizations leveraged these foundation models and generative AI to enhance various aspects of their operation? And given that it started in the US, how would you compare adoption trends in the US versus those in the ASEAN region where we are today?
Yeah, so it's very interesting because for many years now, enterprises and organizations have been trying to adopt AI in general into various business processes. But over the past couple of years, as we've seen, the rise and adoption of some of these very powerful foundation models, we've seen enterprises kind of, accelerate that type of deployment. Now we're seeing use cases of foundation models being adopted in, things like customer care, helping customer care representatives better serve their callers and their customers. Think about HR use cases, right? How are large language models helping enterprises engage with their employees in a much more efficient way through different types of HR use cases, but also in more creative areas like marketing. So when we think about marketing, we're seeing a lot of use cases around content generation, right? Whereas before it took many people significant amount of resources and time to generate new marketing content, new ad copy, right? And even thinking about hyper-targeted personalized ads, now we're able to use large language models to automate and accelerate a lot of that work. And the second part of your question, so you mentioned we saw the initial adoption and rise in the US, right? So we've seen primarily a lot of these large language models being, trained and built around English, right? But what I've been very excited to see is the mass amounts of activity and acceleration in the open source space, especially for countries in the ASEAN region, where I'm actually seeing, out on the Hugging Face marketplace now, a lot of different models that are specialized for Southeast Asian languages, right? So they're taking base models, for example, llama type models from Meta, and adapting them to different regional and local languages. Right. So, and as we see the rise of that, we're going to kind of see the same use cases that we're seeing in the US to accelerate much faster here in the ASEAN region as well.
So it will be a Thai version of the same foundation model, but it's in Thai and it's adapted not only to the language, but also to the culture of that country.
Exactly. So I'm glad you brought that point up because there's some very nuanced points around it, right? So whereas you have a standard model that's trained in English, you're not actually necessarily looking for a model trained in pure Thai, right? And it's the same for other languages, such as languages in India, where the local people don't speak, pure versions of that language, right? It's oftentimes a mix of the local language and a little bit of English thrown in there, right? So you actually have to have models that are trained on, certain dialects and are able to adapt to mixes of, English words, the local language, and, different types of sayings that may not translate directly in the context of English.
The slangs, okay.
Exactly.
Yeah, okay. So what would you say are the key successes organizations hope to achieve by adopting generative AI, and what is stopping them, or what would stop them from achieving those goals?
Yes, great question. So, I see it as the goals that organizations are trying to achieve is the same that it's been for many years, and that is to surface actionable insights in a quicker manner, right? Now we're seeing that accelerated through generative AI, but the challenges are the same challenges that organizations have faced in the past. It's how do you build a robust data foundation to power those kinds of use cases? Because if you don't know where your data is, you don't know the quality of your data, right? You don't know how to pipe and integrate it to get it to the right place, you're not going to get valid outputs from generative AI workloads. It's garbage in, garbage out, right? So we need that robust data foundation. That's what's going to enable organizations to be successful in generative AI.
So generative AI arguably has reached that hobbyist phase, and as computers evolve, or software and technology evolve, further progress aims to attain greater performance in smaller packages. What's your interpretation of this question?
It's very interesting when we have new technologies come into the marketplace. You see that very quick run-up of a lot of noise and excitement about it, right? And I think we're kind of at the top of that phase, as you mentioned, the hobbyist phase. But now, as we're seeing businesses and enterprises trying to adopt this technology for business critical use cases, we're now starting to see some of the challenges of what it actually takes to operationalize this technology, right? And one of the examples of that is we saw a lot of excitement with every new release of a new type of more complex large language model, right? Now we're hitting that point of, in my opinion, diminishing returns, right? Where the expectations are so high now for these new models, and as they come out, the performance enhancements and improvements are less so than they were maybe a year ago, right, as compared to a previous model. And especially now when enterprises are trying to adopt these, they're really hitting a wall, right? Because there's only a certain amount of internet data or public data that you can use to train these models to get, as high performing as you can. But now as enterprises try to adopt these models for very specific use cases, they're hitting a limit, right? They really are now looking towards smaller, more targeted models that are trained on their organization's proprietary data, right? So for example, you look at a customer service use case for a credit card company, right? You have callers calling in to the customer service department, and you have representatives trying to understand the caller's problem and intent and provide them the most relevant answer, right? Well, that whole process can be made a lot more efficient if the large language model that you're using has been trained on a vast trove of call log data from previous calls, right? This is not something that's in standard general large language models, because the intent of these conversations is very dependent on that organization's specific use case. So now we're seeing a lot of customers and enterprises take smaller models and enhance them with their own company's data to make them much more targeted and accurate for very specific use cases. And by the way, at significantly reduced compute requirements. That is one of the things that we're seeing become a major obstacle and challenge, right? Yes, very large language models are great with a lot of parameters, but we're hitting a limit on how much compute we physically have access to, right? So we're going to have to go to the path of smaller models, more targeted, more efficient.
Now, it is said that there is no one-size-fits-all. Organizations, as you said just now, want the right model for the right use cases.
Yep.
Okay, they also need to be able to use their own model based on their needs. what's the argument for them not to go there? Now, because as you said earlier as well, the initial perceptions around what Gen AI can do is hitting a brick wall because it has to be tailored to the specific requirement of the business.
You can throw as much compute at a problem to solve it, right? But cost economics become a valid concern as well, right? If the initial use case that we're trying to solve, if the goal of that is to be more efficient, but it takes more resources than we have, then it's not worth it, right? That's kind of the whole catch-22 with this whole generative AI challenge, right? That's why we're seeing enterprises go to more fine-tuned and targeted models now, because they want to be able to benefit from the enhancements of generative AI and all the innovation, but they want to do it in a way that makes economic sense and is efficient from a compute perspective, right? The other thing is that they also want to do it in a way that's compliant, right? So I'll give you an example. Imagine, the two major aircraft manufacturers in the world, right? Now imagine if one of them is using a large language model that's very general, it's been trained on a vast variety of data. Now, if they have a challenge in that, in the output of it, and it goes into litigation or a court of law, and it's found that the other manufacturer's data was actually used to train that model on how you certify aircraft, that's a major red flag, right? How can organizations be sure that there isn't any intellectual property in the underlying training data sets that would be a major compliance concern from them, right? That in itself is steering enterprises away from these very, very large models and forcing them to basically build their own models, right? That's very targeted and specific to their organization.
Can you cite an example of how the use of customized language models are able to bring better benefits that compared to if we're using just generic models?
Yes, absolutely. So one example there is in credit card fraud detection, right? So it's very dependent on the credit card company and the history of its customers, right? And their purchasing patterns. Only the credit card company knows that context and history. When I think about these models, it's all about context and what kind of knowledge has gone into the training data set. So for example, the purchasing patterns and history of millions of credit card consumers is not baked into a large language model that you can get off the shelf. That's going to be proprietary data that's in the enterprise. And if they use a very general model to help with fraud detection, it's not going to be as accurate, right? I'll give you an interesting fact. 80% of the data in the world today is actually enterprise data that's behind their firewall, right? Most of the large language models that you see that are these very complex high parameter models, well, they don't have that 80% of the data in them, right? It's trained on internet data, right? So if organizations want to get very high accurate outcomes, well, they're going to have to start leveraging their data that's behind their firewall to make these outputs a lot more accurate and a lot more efficient.
So what exactly do we mean by BYOM?
Yeah, so that's a great question. So, we're seeing a lot of innovation rapidly in the open source space, and also on the enterprise side, where enterprises are going out and building their own models, right? But as vendors of generative AI platforms, we can't incorporate every single model into a product or an offering, right? You'll see that with all the different vendors. And as we go closer towards enterprises adopting hyper-specific targeted models for very specific use cases, they're going to need a lot more models that come out of the box from different generative AI vendors. And that's where the ability to bring your own model comes in. So there may be models that are out in the open source community, perhaps on Hugging Face. There may be models that an organization's own developers have created specific to their use cases. Now we have the ability to bring those models onto an enterprise-grade platform, right? So you get all the benefits of having an enterprise generative AI platform from the perspective of governance, monitoring, availability, right? But you also get to benefit from all the performance benefits, accuracy, and ability to apply models to specific use cases that you get on the open source side. So we're combining those two with bring your own model.
So there's been a lot of discussions recently about the potential risk of artificial intelligence. Now, will the use of bring your own foundation models reduce these risks or actually increase the risk?
Yeah, great question. So the answer is kind of yes and no. The answer is no because if you're using your own custom models that are trained on your organization's own data, well, you're minimizing the risk of having third-party intellectual data in there, maybe other PII that's leaked into the training data sets of other large language models. But it only reduces the risk if you put into place your own frameworks and tools and governance processes to make sure those same challenges aren't appearing in the data sets that you're using to train the models, right? So if organizations adopt strong governance frameworks and tools like the ones that we have at IBM, then the ability to bring your own custom model onto a generative AI enterprise-grade platform can reduce governance risks.
Luv, thank you for joining us on VODCHATS for FutureCIO.
This has been a pleasure. I've really enjoyed this conversation. Thank you.